Let me just verify if we are live. Yes, we are live. So, good morning, viewers of Thousand Miles AI. Wishing you a good Sunday weekend. And today we are very excited to be here. And we are back again with Shibin. If you are following our previous videos, we already talked about a lot about in software engineering how things have changed. Then we talked about Opus models, Kimi models in the previous session. But Shibin, today, the whole idea is since we were also discussing and also with talk to many students and other friends, right, colleagues, etc., who are also very early into their software careers. They are kind of anxious now, in a way, like they are able to develop apps, they are able to wipe code, etc., right? But that's not as good for a quick demo or a MVP. But when you want to put something into production for customers and bringing that reliability and able to run the system for a long time without having losing your sleep, what is needed was the most heard question. We are hearing this question. I'm pretty sure you are also hearing the same from many of the people you talk to.
Exactly.
Yes.
Mhm.
So yeah, the whole idea now is like what we planned is we will start a series of starting with I think you can talk a little bit more about it, but the whole idea is we will start a series of talking what is needed beyond coding, right? This is about the systems, the system, how to think about the systems, how to design the systems, what are the aspects. Like it's not just you build and you deploy, it's everything is over. There are many things to take care. I think building the first, whenever you write a software, you probably write for like 3-4 years running, like a long-term vision, right? At least handling customers, having like minimum maintenance and all this. There are a lot of aspects beyond just writing coding. So in that sense, we want to start this as our first session where we will talk a little bit about what what are the main aspects in system design which one must master or at least have an idea about to think in systems level, and how they can leverage our sessions. We will talk one concepts and how they can start. It's a what we want to give is not to give a full technical 3 hour teaching. We want to give them an intuition, right? And how to get started into these things. So Shibin, yeah, I also let you add your
Yeah.
points. What's your thought on the sessions and
Yeah, we've been interacting with students, right? I mean, we've been interacting with students from colleges. Also, I have personal experience mentoring like couple of folks in company. Also, I try to talk to all these new grads. I mean, my main intention is to understand the thought process, like about multiple aspects, not only related to the technology, right? So what's my personal experience is what's happening in industries like I think we discussed it one time before, but mostly whenever we joined the industry, the expectation was like you start programming a bit by bit, like write a one class or like couple of functions, fix couple of bugs, then you get to know about the higher level of the things.
yes.
Like you fix a bug, you know how bit of system is working, then you write a like couple of function, you understand like what is the coding standard, then you write a couple of classes, then you understand the abstraction concept, then goes on, right? Like you get into the system design, then you understand why some choices are important, why some choices are not important, like why we made this choice. But this LLM, what's happening, at least in my mind, I think most of the expert also agree on this. what's happening around is that coding part is kind of LLM automated, right? They have everything right now. Like I see folks are using, I mean, myself also use, even for like Git commit, you use LLM to do, okay, like commit it and push it. Like
Yeah.
they don't even understand the basic commands. That's okay. I mean, there are two philosophical way of look. I mean, there are two ways of looking into it. One is like you don't have to understand it because in software industry, people were working on like higher level of abstraction over the year,
Yeah.
right? Like
Yeah.
it was like zeros and one. People used to
Yes.
use the punch cards, type it. Then it became like programming language like Pascal, C, which is more like system oriented. Then you like most of the folks nowadays work on Java or Python unless until you are into some optimized code path, right? Like
Yeah.
yeah, Rust is picking up also. Uh, so the one of the thought process is like you don't understand
Mm.
any of this thing. You work on an abstraction. That's perfectly fine. So what is this abstraction? That is the question, right? Abstraction in my head, it's nothing but system design.
Mm.
Now, if you, if you are white coding any project, right? Like you're creating a website, you can ask, hey, ChatGPT, Cloud, give me a design, it will write something. Then you blindly trust it and let it run.
Yeah.
It can work out, but doesn't work out in industry, right?
Yes.
The thing with white coding, I have seen a lot of people like, hey, Claude is here, Opus is here, like, hey, let's white code this. I mean, we even
Yes,
did
we
once,
used to do
right?
that. Yeah.
Yeah, the problem for all this thing, it's perfectly fine. Like whenever we were not calibrating the entire efficacy of the model. We want to see like which all aspect it understand, right? But when it comes to the industry, when it comes to a standard enterprise software, or when you have customers, when if it's not large, it may be like 10 or 50 or 100 or 10,000, then there are a lot of other aspects comes to in picture, like reliability, be it security, like uptime. So all these additional aspects highly depends on how you design the system.
Yes.
So I mean, we've been having this discussion, right? Internally, like what should be the next thing which would help the new grads or students or even like experienced folks who have been working on a limited space.
Yeah.
Like I know the consultants who are like uh, who are expert in like SAP consultants, say
Yes.
for example. I know a couple of them. They are like very specific into a couple of topics.
Yeah.
Due to the time pressure, they didn't get time to upskill themselves. Considering all those folks, I think it's right time they understand the basic fundamentals.
Yeah.
Then you use these LLM tools. That's where this 10x, 15x comes into picture,
Yes. Yes.
right? Without that, you can be 100x white coding, but it's not gonna work.
Yeah.
So we've been, myself and Praveen was talking also, we've been asking a couple of folks around like what should be the topics we should be presenting. And after a lot of deliberation, we decided this could be the one of it. And we'll have other parallel tracks also. In this track specifically, we are going to start on the basic concepts. Like, I mean, system design is a vast area. Like, I know like some of the folks who prepared for this interviews, they may go and watch some system designer interview, like how the Instagram is built, all this nonsense things. I mean, it's not nonsense. I mean, all these things. Uh, but we are taking a different approach. We will learn from the building blocks. Then we'll put all these things together and we'll have a couple of system design session also. Also, with the relevant sections, we'll have a system design corresponding to that, like not worrying too much about the other things. So the current plan, for the audience, I mean, who are attending today or watching after the live, we are kicking start with the concept of caching first, because that's one of the one of the thing very close to my heart, as I think yours also.
Yes.
Uh, we'll start with this, the basic concept of caching. Then we'll like have like 5-6 sessions on caching, ending with a I wouldn't say fully fledged, semi-fledged system design using the concepts we learned. Then we will switch into another topic. Maybe that's something up to you, audience, as well. Like if you want to
Yes.
stress on database or locking or the thing, will you can also express your opinion. Then we will switch into other topic.
Yeah, completely. Yeah.
That's yeah.
Yeah,
Okay,
like
Vikram.
let's start with caching as we because that is also
Mhm.
one of the biggest pain point, right? Like whenever a customer wants something fast and there is cost aspect, there are many aspects to why we do caching. So
Mhm.
I think we will talk about this in the multiple sessions, but let's start with basics today. And as Shibin
Mhm.
mentioned, please guys share your thoughts, like what topic you think you want us to talk about, and we can definitely plan future sessions based on that. So yeah, Shibin,
Yes.
let's maybe just go into the topic. Okay, why? Maybe you want to just give an
Yeah.
introduction. Why, in general, where do we need caching? Where the everyone's day to day life, where
Yeah.
they might have seen caching, but they never experience it, right? Like it's things happening in the behind. But yeah, maybe you can start with that and
Yeah. This session, I mean, this session we are mainly aiming for that, like just uh, like setting the context, I would say.
yes, yes.
Uh, Let me start sharing my screen.
Yeah, I just allowed, gave you.
Okay. Yeah.
Yeah.
Yeah. Yeah. To talk about the caching, right? It's everywhere, but it's like the oxygen, right? It's everywhere, but it's not visible to you. I feel that is a correct example for caching. Like,
Yeah, it's
I
everywhere.
can't think of a system which doesn't have caching. Like, use touch any software. Like, not even software, right? Like, hardware side. Caching is
Yes.
everywhere. Like,
Even
that's why.
LLMs are also doing a lot of caching, right? You are doing conversation, and there are internally also a lot of
Correct.
caching. Your conversation are also like somewhat will be cached and kept in context.
Even that key value caching, right?
Yes, yes, internal model level.
That
Yeah,
that is, yeah. I mean, I don't want to, because I'm not sure about the audience whether they understand this, like internals of key value caching. But yeah, I mean, caching is everywhere. That's how I feel it. I think I don't know, like people uh, take it lightly, but the closest example I could think, the one of the personal closest thing for me is like how our browser optimize the things, right? This is
yeah,
our website. So
yes,
let me show, let me open the inspect. Um,
yeah. Let me just yes, go ahead.
okay. So I'll show you something first, then we can talk about it. So we have a couple of images,
Yeah,
right? Now you see this 304s, right? Like the address status is 304. Like, don't worry too much about it. Like all this HTTP REST and all will come later. But the status is 304. What does that mean? Means basically browser is calling the server where we hosted the things, saying that give me this image, right? What happens behind the scenes is server is saying that, I mean, what it tell is if this image is, I mean, I have a copy of the image which is on this date. send me the image if it's modified, else don't send me the thing.
Yeah.
So this is an internet standard. I mean, we'll get into all this topic later, but on an abstract, you can think like that. And what the server is responding with it is, if you see, this is not server, this is a cached response actually. It's loaded from the browser.
Yeah.
It's saying that, hey man, this image is not loaded. Keep it. Now, if I disable the cache, hope it works. I don't want to. See, it sits to 200.
Yeah.
So, what happened behind the scenes is now you don't send that thing. Now you're fetching
From the
image from the server.
yes.
So, I mean, if you see the time it took is to transferred. Let's see. Okay, let's see. Okay, so it took 244 millis started. Okay. Total 1.6 second, right? Now if I see, I mean our
Took from cache.
it's 88 for 44 milliseconds.
I think it depends on the
So
file
now
size
you
as well, right? Like now it's small, so you don't see
Correct.
much of the difference. But if it is a bigger like image, high resolution image or video, I mean video is different, but still like bigger file, we might see the real differences. Where if you have to load hundreds of images in your page, that makes the bigger challenge, right? Yeah.
Correct. So now you think about this thing, right? Now internet, everything has to be flown through the networks and get the result.
Yeah.
Now you think about like a website like Google. We can probably try the Google also. Yeah. I don't want to just have some image. It should. There's. I don't want to open my Gmail, but Google image.
Yeah, maybe image search.
Oh shit. Yeah, it will go to my personal.
Okay.
But you take any other example, right? Like maybe a newspaper, maybe New York Times. Oh, doesn't allow. Okay, at least it has some images, right?
Yeah.
And now you think about like I mean, our website is comparatively lower traffic, right? Now you think about a website like New York Times. This 1 second or like it may have better cache, like network delivery altogether, but think about the network bandwidth we can say when like millions people are accessing the New York Times, right? So it's a huge benefit. So it overall reduced the entire internet bandwidth, like the accessibility of the internet bandwidth. Also, it save money for me.
Yeah.
If you accumulate it, right? Like most of the people play around like 10 or 15 websites on a regular basis, like Gmail, blah, blah.
I think that is still less. Probably it's going to be even more nowadays.
Okay.
Or website or like media in general, the consumption of media, like I saw
most
average 2-3 hours people spend on phones, mobile, like tab. So probably it's a lot of data. Yeah.
So all this, if you see that scale, right? Like it could be like 1 millisecond, like not 1 millisecond, like 200, 300 milliseconds, say, or like based on like 100 millisecond, and like some few KBs. But if you look at the large scale, right, it's a huge data set, like huge saving. Like, I mean, you can be an environmentalist and say that it's saving the electricity because someone doesn't have to read and transfer this file.
Yeah.
this is one layer of caching, right? The browser one.
Mm.
It's what's happening locally, and there are like uh, other layers. Like there is CDN caching, which we'll touch
Yes.
upon later. That it always each of the layer has its own caching.
Yeah.
So you never, knowing or unknowingly, you are using the caching logic lot. I think it's one of the most uh, foundational thing
Mm.
which used, and most of the I've been the other day I've been talking about talking with a guy who is like um, into industry for like 4 5 years. They never explicitly understood the concept because like this browser caching, right? You never set it. I mean, it's all comes out of the box for you most of the
Yeah.
time. So you never get to learn about it. I mean, yeah, that's the nature of software
Yes.
engineering, right? Let's field is fast.
Yeah.
Yeah, one that's the one example. I hope audience got a high level
Mm.
understanding or things of how important this is. Other example other example which is close to me is maybe our computer itself, right?
Yeah.
Like, uh, I don't want to get into the hardware part or something,
Mm.
but assume you have a file in the disk, you read that file, right? And you have, uh, if you're not too familiar with all this software concept, whenever you go and try to buy the computer, right? You've been advertised saying that you have this much disk space
Yes.
or HD space or SSD space, and you have this much RAM. Uh, I think all these computer science folks understand these various systems are there, like memory, disk space, and most of the people doesn't care about the CPU level caching, but there is one more layer of things, right? So it flows into, if you look at any device, like be it your computer or like phone, it, it itself has various level of memory and caching. Say, for example, your disk may be 2 TB. It's very cheap. I mean, with all this LLM thing,
Yeah,
it's getting
it's
uh,
crazy now, but relatively cheap.
costly.
Let's say relatively cheap compared to.
Yeah,
Yeah.
I yeah, either you have an SSD or a hard disk, right?
Yeah.
Like the old hard disk of, that rotating thing,
Mm. Yeah.
not solid state, and you have RAM. Let's not get into what RAM is and all. Like it's another layer of memory. So it is maybe 8 or maybe 16 GB or maybe 32. And if you have money, you can go up to, I think, 128 GB nowadays.
Yeah.
Then you have, there is, CPU is the one processing your all the things, right?
Yeah.
And there is one L1, L2, L3 cache. Like, let's call CPU cache. Let's not complicate. Which is very smaller, like maybe like MBs. It's going to be like KBs, MBs, like 250 KB. The things is, whenever a data required, this will take kind of a couple of millisecond to get the data. This will take somewhere around 100, 500 nanosecond. Depends on the provider
Yeah.
and you have. This is one, depends upon the cache. There are multiple things there, but for simplicity, think about like this is 1 to 10 nanosecond. So what happens whenever you run a thing, each of this layer keep the things in their space so program can execute faster. One concept I want to take you from this thing, like when I first understood this concept of caching, my first thing, the first feeling I had is, why don't you cache everything,
Yeah.
right? Like, if it's so fast, so good, why don't you cache everything? In browser, we have seen you can't cache everything because there is a files can get updated and all
Yeah,
those
there
things.
is a
So
dynamic
you want to
content
keep
flow,
on
right?
checking.
Like it's not always static
Mhm.
and things are changing. Yeah.
Yeah, we'll talk about this thing later, but in future session. But cache invalidation is a problem. Now there is another aspect. Like whenever you cache, the cost associated with this also high. Like CPU cache, the cost for that thing
The hardware.
is very high.
Yes.
Yeah, RAM is too pricey. Like if you want to get a like 8 GB RAM, it costs nowadays around like $120 or like $250. I don't know the exact price. In some that range. But if you want a disk of like 1 TB, 2 TB SSD, I mean, I don't know the current price. I got it for like 1 TB SSD, which is like a smaller one, for like $90 or something.
Yeah.
1 TB itself. The other one is 8 GB. So cost is also and one of the main reason why you can't cache everything. So this so yeah, I mean that those are the two concepts I want to stress. Like, I mean, mainly caching is everywhere,
Yes.
including your hardware, like browser or like internet. Even like I can talk for hours on where the caching is used.
Yeah,
Like
yeah, yeah. So
domain resolution, right?
yes.
Like whenever you type google.com, you need to get IP, right? That
Yeah.
mapping is cached.
Yeah.
Locally is cached, DNS server is cached.
Yes. Exactly.
Correct. So the point is, caching is everywhere. It's one of the main concepts you should understand whenever you get started on the software. Second aspect is you can't cache everything for all the time because there is a cost associated. I mean, the varying cost associated with each of the layer. We'll touch upon it. Also, the invalidation of, right, like when the artifact goes irrelevant or get replaced.
How you handle and yeah.
Correct.
Yes.
And yeah, I hope I motivated people to learn about caching at least through
Yes.
our channel
I mean,
or somewhere
the
else.
thing is like from my bachelor's, what I recollect is it completely depends on the motivation you get from operating systems, because that's where I think we are getting introduced to caching, right? First time. So if you get a good, really good, maybe the professor who can really give you a good intuition of how operating system works, probably you will be really hooked to this topic. I think we had like not so interesting professors, so it was kind of yeah, I don't care at that time. But later, yeah, definitely you understand the value of caching in like almost everywhere. So yeah.
Yeah, man. I mean, it is the most important. Like, there are caching. Like, I don't want to like open up the surprise for the future now, like the Redis and all those things, right? But yeah, I mean, it is a in software engineering. If you are learning some system architecture concept, this is the most one of the one you have to need. Like,
Yes.
you think about this problem, right? The Instagram. Say for example, Cristiano Ronaldo. His feed is accessed by millions of people, right?
Yeah.
Now assume there is no layer of caching and everything. Like the Cristiano uploaded photo, it's stored in a file like which is in the disk, which take millisecond to respond. Now assume like everybody start reading this
Yeah.
without any caching there. There are like, I don't know, he has like, how many
Probably
followers?
500,
Maybe
700, 800 million followers. I don't know the exact numbers.
out of that, 10 million see that post,
Yeah.
and same time your server will like burn up. I mean, there are other technologies also, other system design aspect also in
Yeah.
play, but assume there is no caching, like you're goner.
Yes.
Like same with Twitter also, right? Like you tweet, it push to other feeds, but whenever there is an image access and all those things, right? Some few of them has like a lot of view at the same time. How do you
Yeah.
how do you efficiently serve those customers? And Google.com,
Yeah.
like how many people are hitting at the same
Again,
time?
yes, yes. So yeah, Shibin, yes, I think we talked really about interesting topic, and this is, yeah, again, guys, just the beginning of the system design session, and the first few sessions will be caching. And since Shibin, like we are already after 30 minutes now, so I will let you conclude by saying what can our audience expect in the next 2-3 sessions. We don't have to give them the complete plan, concrete plan. We are also kind of flexible. So maybe we can just tell them next couple of session what they can expect, and then we can conclude for today. Yeah.
So next couple of session, I mean, we don't pre-plan the contents too much. So, but what I feel is like next couple of session, we are going to talk about the core concept. Like there are concept like TTL, right through cache, different type of caching. Like you need to understand this to. I mean, my philosophy is like if you want to use something, you should understand why that exists, right? So
Yeah.
there are a couple of concepts and different type of caching
Yes.
things. So we'll talk about that in next two sessions should be enough.
Yeah.
Then we'll get into an industry standard. Like it's not the standard, but most of the people one or other way use. I mean, most famous one I could catch is Redis caching. So we can talk about the Redis, then we can wind up with what I feel is like a real system design, a portion of it.
Yeah, yeah.
We can't talk about a lot about the other system like
Yes.
database, sharding, and all those
Yeah, we
concepts.
will do something.
But yeah, and then we can do it because we want to serve for all the audience, right? Some of
Yeah.
you might have already know about all this concept, but we'll only specifically design that caching layer of couple of applications, then wind up. I think that's the plan. Like, yeah, I mean, of course, you can comment and we are open to hear your response. But yeah.
Yeah. Thanks, Shibin. Thanks for giving this idea. I hope our audience, if you are interested, also please share with us your thoughts. And soon, probably we will come with the next session. And till then, yeah, thanks for the session, Shibin, and have a good Sunday. See you. Bye.
Yeah, bye bye. Catch you later. Bye.
Yes.